Number 8, a wheel spins in a counterclockwise direction. So here's a picture of the wheel. Okay. Fill out the table showing how P travels when the wheel makes each rotation. Okay. So the key with this problem is that this wheel is a unit circle. It's a unit circle because its radius is 1 foot. And in a unit circle, the distance traveled is equal to the angle in radians. Okay? We learned in a very early lesson in this unit that if you have a unit circle, the distance traveled is equal to the angle in radians. Okay? So the answers that we put in this column here are going to be the angles in radians. So what I'm going to do is I'm first going to find the angles in degrees and then convert it to radians. So what this means is if I rotate counterclockwise 1/3 of the way around the circle, what angle am I at? So to do this, I need to find 1/3 times 360. Okay. To find this angle, I need to do 2/3 times 360. And then one full rotation around the circle would be 360 degrees. Okay. So if I go to my calculator, right, let me go to my calculator and do 1/3. Okay. 1/3 times 360 and 2/3 times 360. Okay. The angles are 120 and 240 degrees. So 120 would be the angle 1/3 of the way around the circle, and 240 degrees would be the angle 2/3 of the way around the circle. And then obviously 360 degrees would be the angle all the way, one rotation, full rotation around the circle. So the answers that we put in here are going to be whatever these angles are in radians. So let's start with 120 degrees. Okay, if we go back to our notes, again, I'm going to check this diagram first. And if we look at this diagram, we can see that 120 degrees is equivalent to 2 pi over 3 radians. So that's the answer that's going to go here, 2 pi over 3. Okay, 240 degrees. Okay, let's see if that one's on here. That one is on here. 240 degrees is equivalent to 4 pi over 3 radians. So that's going to go here. Okay. And then 360 degrees, which is if we go all the way around the circle, okay, that's equivalent to 2 pi radians. Okay. That is also on here. So pi is 180 degrees, so 2 pi would be 360 degrees. So that is here. That goes here. So that answers part A. Okay. Okay. Again, because it's a unit circle, the distance traveled is equal to the angle in radians. Okay. B, what angle measured in radians does the point P travel through when the wheel makes 2/3 of a complete counterclockwise rotation? Well, we already answered that. When we make 2/3 of a rotation, okay, the distance traveled is 4 pi over 3. That's also going to be the angle. So what angle measured in radians does the point P travel through when the wheel makes 2/3 of a complete counterclockwise rotation? The angle is going to be 4 pi over 3 radians. Okay. And then C, explain why the distance the point P travels is the same as the angle of revolution measured in radians of this wheel. Okay. Well, we already explained that. Okay. Because the radius is 1 foot, okay, the wheel is a unit circle, okay? And in a unit circle, okay, distance traveled is equal to the angle of rotation in radians. Okay, so this right here is just me writing down the explanation. The radius is a foot, therefore it's a unit circle, and we know that in a unit circle, the distance traveled is equal to the angle of rotation in radians. That is it for number 8.